Good afternoon. Welcome to Sriveda IT. This is DS Prasad, an AI engineer. And in the series of recursion, now we are at the seventh concept. That is nothing but. So, how do I know what recursive call? So, what recursive call to write or how to write recursive logic. So, recursive logic from from scratch. So this is the most important concept of all the recursions. Why? Because in this section only we are going to learn how to write the recursion. So the biggest question everyone is having this one only. So the biggest question. So everyone is having. So how to write recursive logic? Or some members say that. So I understand. So I understand recursion. I understand recursion, but so how do I write? So how do I write a recursion program? So how do I write a recursion program for new concept or problem? New concept or problem. So this is the main important question that all. So I understand recursion, but how do I write a recursion program for a new concept or program, which is more important? For that, we are going to use the one concept called faith method. So faith method or induction method. So we call that one as a faith method or induction method. One of the most interview question also for freshers only. So here faith method or induction method. Before going to what is faith method or induction method, so here we need to know first of all. So here what means never write. So never write recursion directly. So never write recursion so directly. Okay. Never also try to. So try to understand. So never try to understand 100 recursive calls. So recursive calls. Then how? Means instead. So instead, assume. So assume recursion. Recursion already. So already knows knows how to how to solve the smaller problem. This is the most important thing. So how to solve the smaller problem. So never write recursion directly. So we are not able to write the recursion directly. And also never try to understand the 100 recursive calls at a time. So instead, what we are doing is, so we are going to assume, like we are thinking that recursion is already knows and how to solve the smaller problem. We need to find only the smaller problem. If you find the smaller problem, then automatically, so we can solve this any kind of recursion. Okay, any kind of recursion problem. So directly. Next one is golden rule. So of recursion. So golden rule in the sense means like, so we are going to follow five-step algorithm. So five-step algorithm. So where it can uh, give kind of guidance and analysis to write the any kind of recursion problem. Okay. So in this, the first one is step one. Step one, as usual. So what is base case? What is base case? Sir, base case is most important thing. So when should recursion stop? So when should recursion stop? So when recursion stop means only with the help of base case only. So that is the thing. Okay. So every recursion must stop somewhere. So every recursion must stop somewhere. So that somewhere is nothing but called as so base case. So base case. Think of like that. Okay. And if I take any example, sir, can you discuss with the example next? Still, so we have already discussed an example previously. So with that, we are going to see that. So for example, print numbers. So print numbers. So here we have taken a function and it is going to call that function. And after that, it is going to call the smaller function as 4. And that function 4 calls the smaller function as 3. And function 3 calls the smaller function as 2. and function 2 calls the smaller function as 1, and again function 1 calls the smaller function as 0. Okay, function 0. So when n is equals to 0, return nothing. And here, so when n is equals to 1, return 1. So these two are the base cases. So these two are the base cases. Whenever reaches the final base case, and we are going to stop the process and we will print the output. So we will print the output for 5, 4, 3, 2, 1 or 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, any output, like before or after. So that we'll decide. Okay. So that we will decide it. Example. So for example, another example like factorial. So factorial is there. Example. Sir, I want to find 5 factorial. So when recursion stops, sir, when should recursion stop? This is nothing but first question. That is nothing but base case. When should so recursion stop? As I already discussed that. So at 1 factorial, recursion stops at 1 factorial, meaning whenever n is equals to 1, return 1. I already told that n is equals to 0, which is not required. Why? Because so 0 factorial is also 1, 1 factorial is also 1. So I want to stop at 1 factorial instead of again, so one more iteration. Instead of calling that one more iteration, it cost in the sense means like one iteration increases means there is a chance of increasing the memory. So that I want to reduce that one. Okay. So this is nothing but called as a base case. Okay. Also, one more question is there. So what is the smallest valid input? What is the smallest valid input? This is another question in the recursion. So interview question. What is the smallest valid input? Means base case. The smallest valid input is the base case only. Okay. So that is the thing. And then step number 2. So we'll go for the step number 1 completed. Step number 2. So what is the step number 2? Which is nothing but, so what is the smaller problem? So what is the smaller problem? So we need to identify the smaller problem. So how to identify this? Means this is the most important thinking skill. So how can I reduce? So how can I reduce my problem? My problem by one step. This is more important. So how can I reduce my problem by one step? So with the help of different analysis only, we are going to get example for the step 2. So here examples for the step 2. So I want to need sum of first n natural numbers of the 10. Sir, so here I want to find the one step. Okay. So how I'm going to get means one step means just 9. If I know that one, so this is called my smaller problem. So this is called my smaller problem. Sir, I want factorial 8. So factorial of 8. Sir, what is the smaller problem means? Factorial of 7. So reduce one step. Okay, factorial of 7. Sir, I want numbers. I want to print numbers from 1 to 100. So print 1 to 100. Sir, smaller step is print 1 to 99. So print 1 to 99. Reduce one step. Okay. Sir, I want to reverse this sentence like Python. Sir, what is the smaller step means? So reverse YTHON. Okay. So because reduce one step, P I know. So P reversed. Remaining thing we have to reverse. Okay. This is going to take care of the remaining thing. Sir, I know sum of 10 means it will give the result. Sum is nothing but this number is nothing but 10. What about that? Plus after that sum of 9 will carry remaining things. Sum of will carry remaining things. Okay. So here 10. I know that 10. This is the smaller problem. Sir, again, when comes to here, so I know only 9, sir. But what about remaining? The sum of 8 will carry the remaining concept. Will carry the remaining concept. This is the way how we are going to see that concept. Okay. And so this is about something like step number 2. When comes to the step number 3, so step number 3, so which is more important. So here, so and here assume smaller problem is solved. Smaller problem is solved. What is the meaning of it? Means, so here we are having some faith. So faith or trust. So trust that smaller problem, smaller problem will solve. So we are going to trust the smaller problem that it is going to solve that one. Okay. This faith is nothing but called as induction. So this is called as induction method. So we are believing that it is going to solve the problem. So here in these examples, so what are we believing means? What is that? So this is number nine. So some number nine is a so faith because it is going to solve remaining things. And here in factorial 8, factorial 7 is the faith. So when it comes to print numbers from 1 to 100, print 1 to 9 is the faith. Okay. And when it comes to the reverse Python, reverse this YTHON, which is nothing but the so faith or induction. This will take care of it. Okay. So that is the thing. For example, if you need any 5 factorial and don't think like this, like in mathematical ways. 5 factorial means 5, 4, 3, 2, 1. Like this, don't think in programming way. So don't think in this mathematical way, but think in the programming kind of logic. Sir, how to remember that? How to think that one means? So 5 factorial is there, right? So I know that 5. After that, 4 factorial is there. And remember, so 4 factorial, I am trusting. I trust 4 factorial will solve. This is nothing but smaller problem, right? Smaller problem will solve the problem. Smaller problem will solve the problem. And when we have 4 factorial, and again, so here 4, so multiplied by 3 factorial. So 3 factorial is the smaller problem, and I will trust that it will solve the remaining problem. So like that, we have to think. So finally, when we have a factorial of 5, so how we are going to write? 5 multiplied by factorial of 4, factorial of 4, and this factorial of 4 will solve the problem, solve the problem, solve the problem. So this is called faith method. This is called faith or induction method. So this is nothing but faith or induction method. So what about after this? So faith or induction method means, so how do I use the smaller answer or smaller problem? So the step number 4. So step number 4 is, sir, as you said, okay, it is, but how to use that one? So how do I use smaller answer? Smaller answer. Sir, already we discussed this. How to use that one means, for example, if you are writing factorial, so factorial, if you are writing factorial, let's see that factorial of 5. Sir, how to write that one? So as I said that, so this is 5 factorial, right? I want 5 factorial. So first I'm going to take the number and what is the smaller version of it? 4 and I want to calculate the 4 factorial. Sir, how to write this one means if I take a 5 as a n, which is nothing but multiplied by 4 as a n minus 1, and then we are going to this factorial representing in the form of function. Okay. So n multiplied by f of n minus 1. This is nothing but called as a how do I use the smaller answer. So how do I use the smaller answer? Similarly, if you take the sum, similarly, so if you take the sum here, I want a sum of 5. So how to get that sum of 5? Means, sir, we know that sum as a 5, I know, but after that, the smaller problem is sum of 4. I believe or I trust that sum of 4 will solve the remaining problem. See here, if 5 is nothing but n, and then we are going to take that sum of n minus 1. So this is the smaller problem. This is the original. Okay. So this is how we are going to write that kind of logic. Sir, let's write one or two examples so that you will understand that. So what exactly? Sir, def sum of n natural numbers. I'm taking the function name as a sum of n natural numbers. And after that, if n less than 0, so in case negative number, so return nothing. For example, if n is equals to 1, then so return 1. Or otherwise, otherwise return sir number plus, and we are going to call the recursive function sum and change in the parameter as n minus 1. Okay. After that, n is equals to, so after that, n is equals to, we are converting it to the integer and input enter, so enter n value. So n value to find the sum of first n natural numbers. After that, print and call that function sum of so n natural numbers and passing the value n here. Okay. Sir, I want to find the first five numbers. So here I am getting an error. So int object is not iterable. So integer object is not iterable. See, sum of n natural numbers. We need to call the function. So 5 is nothing but 50. Sir, and next, if you take that 50, so here 1275, is it correct or not? I want to test that one. See, we know that the sum of first n natural numbers formula is n into n plus 1 by 2. Sir, 50 multiplied by 51 by 2, so 25. Okay, 25 5 sir, so 125 and then plus 25 means 1275. So this is the correct output that we are getting. Okay. So this is one case. And the next case, sir, I want to find another example. So I want to write the another example. So how to write that one? Means power. I want to write the power. So power in the sense means x power y. Here, so x is a variable and y is also a variable. Sir, we know that take x is equals to 2 and y is equals to 2 for sake of understanding. And 2 power 2. I want to find that. So don't think 2 square, 2 power 1, 2 power 0 like that. So think in a recursion way. Sir, this is 2. Okay. So this is 2 power 2. And next, how to think like that means see here x power y, right? So here, so first I am going to take that x. X in the sense means 2. So 2 multiplied by what about the next one means? So here we need to reduce the drop by 1, right? So 2 power 2 minus 1. Okay. So this will take care of that one. So here, this is the function we need to use here. So how to use that function? Again, that is also we are going to see. Okay. So x power y means, so what is that? 2 power 2 square means 4. We need to get that 4. How we are going to get means 2 multiplied by, for example, if I take the function and here again 2 comma, so here what is that one? So 1 is the nothing but y. So here this is nothing but x. Okay. So here this is the case. Okay. And how I am going to write means 2 multiplied by function of, so here 2 is nothing but x. So x comma y minus 1 reduced or so step reduced by 1. So reduced 1 in the sense means not always reduced 1. Sometimes we are going to reduce 2, 3, 5, depends upon the application. Okay. But here we need to identify the base conditions, which is more important. So what is the base condition here? So the base condition is, so here we have two variables are there. When x is equals to 0 and y is equals to 0, what will happen? Sir, 2 power 0 means what? 1, sir. 1 in the sense means whenever y is equals to 0, return 1. Whenever y is equals to 0, return 1. Similarly, 0 power 2. So 0 power 2, anything to the power of 0, which is nothing but 0 only. So when x is equals to 0, return 0. So these are the base cases. And we know the logic, recursion function logic, this is the one. So how we are going to write? Now let's see that. So how I am going to write? So here, so def and then power. So here, so def power of numbers. So power of numbers. I'm going to take x comma y as a parameters here. And after that, if y is equals to 0, then return 1. Return 1. If x is equals to 0, then so return 0. So why? Because 0 power anything is 0. And after that, so return here x. So multiplied by, so call that function recursively. So power of numbers, and take that x value and then change in the y. That is nothing but parameter change. So y minus 1. So that's it. And here, let's take that x is equals to, so int of input enter, so x value. So enter x value. Similarly, so take that y is equals to, so integer of input So integer of input. So enter. So enter y value. So enter that y value. And after that, so call that function print. So power. So power of numbers, and inside it we need to specify that x and y parameters. See that, yeah, I'm entering the x value as 2 and then y value as 2. I'm getting output as 4. So I'm entering the x value as a 2 and y value as a 5. So 2 power 5 is nothing but 32 only. Okay. So this is how we are going to write the programs for this case. Okay. So here about step number 4. Next, we are going to the step number 5. So uh, this is the most important one. Step number 5. Should the work should the work happen? Should the work happen? So before or after recursion? So before or after recursion? So this is the most important thing, because before recursion or after recursion, already we discussed about this concept. Okay, two functions we have written in the previous cases. So one is nothing but it is printing the numbers. So see this one. So this is the function. So program. So this is the program, and here. So this is the another program. So this is the another program. So here. So this is the another program. See, just this is the recursion call, and this is the work. Okay, recursion is before the after the work, and here the recursion is before the work. So we need to decide that one for the function, whatever the program that we are writing. So otherwise, what kind of output we are going to get, that is more important. So what kind of output that we are going to get, so that is more and then important. Okay. So why because so application, so whatever the application they have asked, based on that we are going to write. But how to decide that one, so depends upon your case. So if you want the output, for example, here you see that this is the output, and here how I am going to get the output means 5 4, so 3 2 1. So here how I am going to get means I'm getting 1, 2, 3, 4, 5. Sir, how would you know? Meaning is so simple that in the upcoming sessions we will learn. But before that, I will just give a hint. For example, here print n work. And after that, so print number. So print numbers. So print numbers. N minus 1 is there. And here print numbers, n minus 1, and after that print n is there. Okay, so now you can see that this is the work. So this is work and this is recursion. So after work, before work. Okay, so this is the work and before work. So before work, this is after work. See, always in recursion, the printing starts from recursion. So whether recursion to the print statement, recursion to the print, recursion to the work, recursion to the work. So here work is above. So from bottom to top approach. Okay. Here recursion to work means from top to the bottom approach, top to the bottom approach. So in this case, so there is a call stack will be there. Call stack will be there. In the next cases, we will learn call stack here. So memory is there, and each stack frame is going to save. Each stack frame is going to save. So f of 5, f of 4, f of 3, f of 2, so f of 1, and f of 0. F of 0 is the base condition. This is the top and this is the bottom. So here, this is the top and this is the bottom. Sir, for both or any kind of program, the call stack is same. So call stack is same. And here I told you that for this case, so print and then bottom. So print from, so bottom to up. So bottom to top. So bottom to top. When we are going to print from bottom to top, function 5 will give the output 5. Function 4 will give the function output 4. Function 3 will give the 3, 2, 1. Okay, this is base case only. So bottom to up. So what is the output for this? So 5, 4, 3, 2, 1. 5, 4, 3, 2, 1 for the output for this. And print numbers and then print. So from recursion to the word. So top to bottom approach. So top to bottom approach. Top to bottom approach means 1, 2, 3, 4, 5. So here, this is nothing but ascending order. So this is nothing but descending order. So this is nothing but so descending order. So ascending order is nothing but called as a head recursion. So head recursion. So why we are, how can you say that head recursion means? Because recursion is first, after that work is there. So this is head. So head recursion, and this is called as a tail recursion. So tail recursion. So every recursion program follows whether it is going to be a direct recursion or indirect recursion or finite recursion or infinite recursion, head recursion, tail recursion, head recursion, tail recursion, tree recursion or nested recursion. So every program follow these kind of things only: one, two, three, four, five, six, seven, eight. So infinite infinite is nothing but recursion error without base case. So only seven cases. Every problem is a finite. So defaultly we need to remove this one because every recursion problem is a finite only. Okay. So we need to think about the six cases. Again, in that six cases, whether it is a direct or indirect, how to know that one? That we will learn in the upcoming sessions. Okay. Now we learned about the five-step algorithm, which is more important. This session is more important. Step one, what is the base case? So when should recursion stop? Step two, what is the smaller problem? So step three, so assume smaller problem is solved, faith or induction method. So how do I use the smaller problem? Is using both current. So should the work happen before or after the recursion? For that, we have discussed these two examples. Okay. Now what I will do means I will explain these complete five steps at one go. Means complete example. So complete example. So understanding. So example one. Sir, problem is, what is the problem? I want to print numbers from 1 to, so print numbers 5, 4, 3, 2, 1. So what is the steps we have to follow means step one. So base case, sir. What is the base case for this means we have to think of it. If n is equals to 0, return nothing. So return nothing. Okay. And step two. So what is that step two? Smaller problem, which is more important. What is the smaller problem? So here, so the smaller problem is print 4, 3, 2, 1. This is a smaller problem. Okay. Rest of the thing is a smaller problem. And what about step three? So step three is nothing but faith or induction. Faith or induction. So induction. Assume. So assume function 4 print correctly. So print correctly means solves the problem. This is smaller problem. So solves the problem. Solves the problem. Smaller problem solves the big problem. Okay. What about the next step four? Current work. Current work combine. Current work combine. So current work combine. What is the meaning of it? Means we need to print that 5. Okay. So next step 5. So in this we are going to take that. So n plus, so function of n minus 1. This is the combine. Okay. Current work. I want to print 5 and also I want to call the recursion. So this is the thing. When it comes to the step 5, before or after. So before or after we need to decide that one. So before recursion or after recursion, we need to so decide that one. This is the case one example. And similarly, so I want to print the same case with help. So but this time 1, 2, 3, 4, 5. I want to print this one. Okay. Sir, base case step one is same. So step two is also same. So step three is same. Step four is also same. When it comes to the step five. So we need to decide that before or after. Before or after. So check, we need to check that. See, previously this is nothing but, so what? From bottom up approach. So bottom to top approach, right? So bottom to top approach means, so recursion, so after, okay? So this is after work. So this is nothing but before work. So before work. So the only difference is this one, sir. So from these two example cases. And if you want another example, then let's discuss about example factorial. So if it is factorial. So I want to need 5 factorial. So what is the base case here? Step 1. So base case. Whenever n is equals to 1, stop. Return 1. So return 1. So second one is smaller problem. So what is the smaller problem here? So 4 factorial will take care. So take care of everything. We no need to think about what will happen in the 4 factorial. Okay, it will take Take care. In the step 3, it is nothing but faith. Means, so factorial 4 solves problem. So already work. So solves the problem means already works. Okay. 4 combine. So how we are going to combine the current one? So 5 multiplied by factorial of 4. So this one. And fifth step is, so before or after. So before or after. So that we need to decide. Okay. Before or after. Okay. So we need to decide this one. So max most of the time. So we are going to take that. So which case that we will also see that by knowing the number of, by writing the number of examples, then we will understood that. Okay. So similarly, if we can take this one. So another example like reverse string. So reverse string. So how to reverse that string? For example, if you take so ABCD, sorry, ABCD, I want to take. First step is base case. Sir, what is the base case? Think of about this base case. Whenever the string is equals to empty, string is equals to empty, what will happen? We need to stop there. Okay. String is empty means we need to stop there. So that is the base case. So what is the second one is smaller problem. So smaller problem. So that is nothing but BCD. So BCD is the smaller problem. Third one is nothing but faith. Faith is nothing but BCD works well. BCD works well in the sense means like DCB. This is the output. Okay. This is the output. Fourth, current work. So current work combine. So how we are going to combine that one means, so we are going to append A plus. So here, yeah. So DCB plus A. So DCB plus A, which is nothing but, so combine the current work. So output will become, so DCBA. So DCBA. And fifth one, so before or after. So before or after. So that we need to decide. So that we need to decide how to decide that one. By writing the logic, we will get that one. Okay. So this is about something called as different examples. And the next case in this is recursive problem template. So recursive problem. So template. So recursive problem template. So what is the meaning of recursive problem template? Means whenever you are going to write any recursion, so here we need to remember this one. So def, so recursive, so function name, so recursive function name, and inside that we are going to take the parameters. So parameters. So we are going to take the parameters, and here, so the step one. So the step one is nothing but, so base case is the step one. Okay. So here, if base case. So for example, it reached the base case, then so return something answer. So return some answer. So whatever you want. So after that, so here next step two. So what is the step two? So step two is nothing but smaller problem. Smaller problem. So smaller problem. And then step three. So step three is nothing but, so faith or induction. Faith or induction means believing. So believing. So believing a smaller problem will solve. So believing smaller problem will solve. So will solve problem. Will solve the problem. And after that, step four. So what is that step four? So combine. So combine current. So current content. So combine. So current concept. So current concept. Okay. So after that, so what is this step five? So step five is nothing but, so here we need to return the final answer. We need to return the final answer. So also decide. So also decide. So before or after. So once after deciding before or after, then we are going to get the, so final answer. So decide before or after, and after that return final answer. Here, so return the result means combine the current concept. We need to combine the both. So smaller problem and then problem. Okay, that is the thing. So this is called as a recursive problem template. So every recursion function follows this kind of thing. And after that, So recursive thinking. So what is meant by recursive? So thinking. So recursive thinking is nothing but called as so how to think and how to write that one. So program. Here question one. So for question one, so when should recursion stop? So when should recursion stop? So when should recursion stop? We know that when base case is there. So base case, when it reached the base case. Question two. So the steps are nothing but the same thing. So what is the smallest smaller problem? Smallest problem or smaller problem? What is the smaller problem? So question three. So faith. What information should I pass? What information so should I pass? This is nothing but called as faith. So faith or induction method. So also faith or induction in the sense means parameters. In the sense means so parameter change. So we need to identify the parameter change. So here next. So question number four. So when what current function should do? So what should current function? So current function current function do? That is combine. So combine. Uh, combine current and smaller problem. Combine current and smaller problem. So that is so n plus so f of n minus 1. So this is the case. Okay. And after that, so question number 5. Should recursion happen before work or after work? Should recursion work so before or after work? So after work. Okay. So this is the most important case. So this is nothing but called as so recursive thinking, which is nothing but called as a five-step algorithm only. So which is more important for writing any program. Okay, from the scratch. So that's it. Thank you.